Students, welcome to the cryptography and securities update. We are in module 2. In this session, we are going to look into one numerical example with respect to Diffie-Hellman key exchange. See, as you know, with respect to Diffie-Hellman key exchange, we need to consider public parameters, right? So, what are the public parameters that we are considering? One is the prime number, and the other one is the primitive root of it, right? So let us consider that prime number is 5, and we can calculate the primitive root of 5, which we have seen in the previous session as well, right? So let us consider that the primitive root given is 2, right? So if I consider this as the prime number p, and this is the primitive root alpha. Now what we have with respect to the prime numbers, the prime number and the primitive root. Now we have to select the private keys, right? So the selection of private key. In exam, while solving, the private key will be given to you. Otherwise, if they ask you to take explain the failment with an example, then you can take your own private key. Let us consider that the A, that is who is the sender, he is selecting the private key as say consider 4, and say the B, who is the receiver, say he is going to select the private key as 5. Now, once the selection of private key is done, what is the next thing that we have to do? We have to compute the public key, right? Compute a public key. So, basically, if we consider the private key as in the explanation of the algorithm, we considered it as XA and XB, correct? The private keys. So, XA here in this case it is 4 and XB would be 5. Now what I have to compute? I have to compute public key. So public key is what we are counting. We are taking it as y and yb. So how is ya calculated? It is you know that it is alpha power xa and mod b. Correct. So what is alpha here? It is 2, and xa is 4, and mod 5. So which is nothing but 16 mod 5, which is 1, right? And I have to calculate the yb, which is nothing but alpha power xb mod p. So what is alpha power xb? Alpha power xb is 2 power 5 and mod 5. So 2 power 5 is 32. Mod 5, when you do, you are going to get it as 2. Therefore, you got two public keys, which is ya is equals to 1, and the other one is yb equal to 2. Right. So this you have calculated the public key. So just to tell what we did, uh, for us in the exam, if they are asking us to solve, then they have to give this at least prime number they should give, and these two they should give. Right. So if they are asking us to take and explain, then we can take anything. Primitive root we can compute, whichever comes first you take that. In this case, I'm considering as an example, so I've considered as 2, and we have seen for 5 primitive roots are 2 and 3, right? So taken it as 2. There can be more than one primitive root, right? So once that is done, xab will be given, or if it is asked for us to explain, we have to consider compute ya and yb. Now what we will do, a and B will exchange their the private key, sorry, public keys, and they start calculating the key. So let's key one. Let A compute key one. I mean K1, which is nothing but the public key of B and its private key mod P it has to do. So what is the public key of B? It is 2, right? So 2 power. What is the private key of A? It is 4. 2 power 4 mod 5. So what is the 2 power 4 mod 5? So it is 16 mod 5, which is equals to 1. So K1 is 1. Now B would compute. B has received, uh, right, YA. It has to calculate the K2. So it will use its private key, and then it will do mod. So what is that public key computed? 1, right? So 1 power, what is the private key? 5. And then mod 5. So 1 power 5 is 1 only. 1 mod 5 is what? 1. So K2 is 1. So as since K1 is equals to K2, we say that this is the shared key. We are considering this as the shared key. So this is it. So this is how we the key exchange is done. Thank you, students.